In this tutorial, we will see how to handle quantity discounts with fixed holding cost. In the next tutorial, we will see how to handle variable holding costs. Holding costs could be stated as a fixed amount or a percentage of the purchase price. For example, the holding cost for a can of furniture polish might be given as $1 per year or 15% of its purchase price. The first would be fixed and the second variable because it would vary with the purchase price. Suppose you had an item in inventory for which the basic economic order quantity was $3,162 and you paid $9.75 for it. Would you be willing to buy more if they charged you only $9.50? What about if they only charged you $9.25? That is the exact decision we make when we work with quantity discounts. Buying more than the EOQ raises average inventory and therefore annual holding costs. It also lowers the number of orders and therefore annual ordering cost. Generally, total stocking cost goes up. That is always the case with fixed holding cost, but not always with variable holding costs. So, if the increase in the total stocking cost is more than offset by the reduction in the purchase price, you would take the discount. Likewise, if total stocking cost goes up more than the purchase price goes down, you would not take the discount. The steps are as follows. First, calculate Q, the economic order quantity. With fixed holding cost, there will only be one Q regardless of the purchase price. In the next tutorial, we will see that there is a separate Q for each price category when there is variable holding cost. Second, adjust the Q value for each price category. This will make more sense when we work an example. The calculated Q value will only be valid for one set of prices. It will be too high or too low for the other categories. Being valid is called feasible, and being too high or too low is called infeasible. Third, compute the total cost for each price category. A very common mistake that I see students make is computing total stocking cost rather than total cost. You cannot make the decision based on total stocking cost. After all, that ignores the very cost we are concerned with. Fourth, make a decision by selecting the lowest total cost. A manufacturer uses about 5,000 components a year. Order costs are $150 and holding costs are 15 cents per component per year. The vendor charges $10 for 1 to 499, $9.75 for 500 to 3,499, $9.50 for 3,500 to 5,999, and $9.25 for 6,000 or more. Determine the optimal order quantity and the total cost for that order quantity. We compute the economic order quantity exactly as we did in the basic EOQ tutorial. That is, the square root of 2 times the annual demand of 5,000 times the order cost of $150, all divided by the holding cost of 15 cents. That works out to 3,162. Now that we have the Q value, we have to adjust it for each price category. For the first price category of $499, you cannot order 3,162 and pay $10. The closest to 3,162 that you can order and pay $10 is $499. So, that is the Q value we will use for the first category. For the second price category, 3,162 is completely valid, so we will leave it as is. With fixed holding cost, Q will be feasible in exactly one price category. For the third price category of 3,500 to 5,999, you cannot order 3,162 and pay $9.50. The closest to 3,162 that you can order and pay $9.50 is 3,500. So, that is our adjusted Q value. For the fourth price category, we must adjust Q to 6,000. 2 notes are in order. First, for price categories that are more expensive than the one with the feasible Q value, we always select the quantity at the top of the range. For categories that are less expensive than the one with the feasible Q value, we always select the quantity at the bottom of the range. Second, while I do not do it here, you can always ignore price categories that are more expensive than the one with the feasible solution. They will never be cheaper than the category with the feasible solution. The next step is to compute the total cost for each price category. This was covered in detail in the total cost tutorial and will not be covered in detail here. By way of review, the total cost calculations for the 6,000 and more category are shown on the slide. Notice in performing the calculations, we used the adjusted Q value and not the EOQ value. That would be the case for all of the price categories. Also note that for the cheapest cost category, the total stocking costs are $450 plus $125 equals $575. This is higher than the total stocking cost for the EOQ price category of $474, but is more than offset by the reduction in purchase price. The 6,000 or more price category has the lowest total cost, so every time we need to place an order, the company should order 6,000. Just for informational purposes, the slide now shows the total stocking cost. Notice that the EOQ price category of $500 to $3,499 has the lowest total stocking cost. That is why this decision cannot be based on total stocking cost. A manufacturer uses 1.25 million components a year. Order costs are $500 and holding costs are 25 cents per component per year. The price categories are shown on the slide. Determine the optimal order quantity and the total cost for that order quantity. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The EOQ calculations are shown on the slide. The resulting Q value is 70,711, which is in the second price category. Using the EOQ value of 70,711, we adjust the Q value we will be using to as close to 70,711 as possible, but to a feasible value within each price category. Those values are shown on the slide. Using those adjusted Q values, we compute the total cost for each price category. Those values are shown on the slide. Finally, we select the lowest total cost, which falls in the $100,000 to $999,999 price category. So, each time they need more, they should order $100,000. This also goes to show that you should not always take all of the price breaks that are offered. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.